Okay, so I'm recording now to explain first, going through the notes a bit like quickly, just to explain what's happening. You can choose to skip this and go directly to the quiz. I don't care, but I'm doing it for your sake. Really, like, whatever you want, wallah. The quiz is pretty straightforward, wallah. It's all memorizing. You can just memorize, but of course there will be stuff that is not in the quiz. So let me open the notes. So it's up until 3.5.7. So according to the notes, it's up until here. Okay. So it's a quick 3 pages. I will go through them extremely fast. Okay, you need to first know we know electrolytes are solutions that dissolve in water to form conducting solutions, right? Okay, a substance that conducts electricity when molten or dissolved in water because of the presence of delocalized ions, which undergoes electrolysis. That is what electrolyte is. Okay, you have strong and weak. Okay, electrolyte can be strong or weak. Let me draw this for you. Electrolytes. Okay, can be strong. Okay, let me move this to the left. Or it can be weak, right? Okay, an example of a strong electrolyte is like NaCl. Okay, when we say it's a strong electrolyte, that means it dissociates completely. Okay, you have these Na plus Cl minus bulbs. When you say it's a weak electrolyte, let's say CH3COOH, meaning it does not dissociate completely. So it will dissociate maybe one. It will dissociate COOH, H plus CH3COO minus CH3COOH. So see here, it only dissociated one molecule to form these two, right? But the rest didn't dissociate. So basically, in weak, it's a partial dissociation. Okay, strong أكيد is a complete dissociation. So, to sum up, a strong electrolyte has a complete dissociation, a weak electrolyte has a partial dissociation. Okay, what are the strong acids? Sorry, an electrolyte doesn't necessarily have to be an acid, huh? It can be a base as well. Okay, so what are my strong electrolytes? Strong, actually, they can be acids, or bases. Let's see. What are my strong acids? HCl, HBr, HI, and HNO3. Okay, okay. This isn't an acid, huh? You know, it doesn't necessarily have to be an acid or a base. Electrolytes can be NaCl is a salt, right? Salts can form. Yeah, you know, usually ionic compounds are electrolytes, right? They can also be acid or bases, like these four, sorry, or the strong bases, like usually any hydroxide, uh, LiOH, KOH, but Mg2 plus magnesium hydroxide and MgOH and calcium hydroxide COH are not strong. Okay. What are the weak ones? I'll write them now. Weak ones are any organic acids. For example, yani it means containing anything containing COOH. Okay. For example, the one we mentioned up, CH3COOH, as well as C6H5COOH, as well as HCOOH, as well. Okay, yeah, these are the examples. So if you were to write the dissociation of, let's say, C6H5COOH like this, you would use a double arrow because it's partial. Okay, C6H5COO plus H plus. This means partial dissociation. Okay. طيب. So a strong electrolyte, water is a weak electrolyte, and its equilibrium constant is 10 to the power of negative 14. Because you know, when you're weak, you have partial, so you have equilibrium, right? 2 arrows means equilibrium. Okay. So its Kw is 10 to the power negative 14. You must know this. And in pure water at 25 degrees Celsius, the concentration of OH is equal to H, which is equal to 10 to the power negative 7. If you dissociate water, guys, H2O, you get OH minus plus H plus, right? So at 25 degrees Celsius in pure water, concentration of this is equal to concentration of this, which is equal to 10 negative 7, 10 negative 7. Okay, so in total, what's the Kw? 10 to the power of minus 14. According to, there are two definitions. Okay, you have you have the Arrhenius definition, and you have the Bronsted-Lowry definition. Arrhenius basically said an acid is a substance that increases the concentration of H+. Bronsted-Lowry said that an acid is a proton donor. Okay? Arrhenius said that a base is a substance that increases the concentration of OH-. Bronsted-Lowry said that a base is a proton acceptor. Okay? Now we usually follow Arrhenius, but you need to memorize both of these. Okay? Many acids are dangerous as they are corrosive. They can eat away other material. La, 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 la. A strong acid is one that dissociates completely, while a weak acid is one that dissociates partially, which is very straightforward. I'm just checking my notes if there's anything that I have to mention. Similarly, a strong base is one that dissociates completely, while a weak base is one that dissociates partially. Examples of strong acids are hydrochloric acid and hydrobromic acid, hydroiodic acid, sulfuric acid, and nitric acid. Okay, I think this is hydrochloric acid is HCl. Usually all the H something, they're usually we wrote these earlier. And sulfuric acid H2SO4 and nitric acid HNO3. We wrote these up here. The strong ones, yeah. So I didn't write H2SO4, but H2SO4 is strong. As the sulfuric acid is strong, it's very good to know. Okay, H plus and OH minus can easily be calculated given a strong acid, a strong base solution of known conclusion. La 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 la. Okay, we're gonna skip these. Okay. Oh, I don't think. Wait. Hello. Hello. Okay. Did they ask it or no? Okay. 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 Let me go back here. If you want to calculate the H plus and OH minus in any solution, here's what you do. You first have to understand that the solution means it's dissolved in what? Water. Right? It's dissolved in water. Okay, if you ever get a question like this, and you're gonna get to more since it's a good question, you will definitely get this type of question. You write the dissociation reaction, okay? LiOH, you get Li and OH minus. You're gonna say, Taboli, I don't have H plus, I only have OH minus. Okay, find the concentration of OH minus. The concentration of LiOH is 0.01. So okay, since they have the same coefficient, this will also be 0.01. ماشي. Okay. You found concentration of OH minus is equal to 0.010, whatever. I don't care about significant figures right now, but I want to make a point. How do you find concentration of H plus? We know it's dissolved in water. Okay, at 25 degrees Celsius, what is equal to K water? It's equal to 10 to the power of minus 14. You guys know, remember that to find the equilibrium constant, it's equal to the concentration of the products, right? So actually, this 10 to the power of negative 14, I should have mentioned it earlier, but it's equal to the concentration of OH minus times the coefficient of H plus. Remember, we said at Shusmo, for pure water, it was 10 minus 7, 10 minus 7. Because if you multiply these two, what's minus 7 times 10 minus 7 times 10 minus 7? Minus 7 plus minus 7 is minus 14. You get what I'm trying to say? Okay, so the equilibrium constant is equal to concentration of OH times the concentration of H. Okay, so in this case, my concentration of OH is 0.01 times, it's now math, times H is equal to 10 minus 14. Divide 10 minus 14 by 0.01, and you'll get, I don't know, let's see, 10 to the power of minus 14 divided by 0.01. 10 to the power of minus 12. That's how you do it, okay? The pH is used to measure the acidity of solution, where pH is equal to minus log H plus. Minus should be log base 10 H plus. Okay, if you get 7, it's less than 7, it's acidic. If you get 7, it's neutral. If you get it should be greater, sorry. Greater. I don't know why they put. It should be basic. Okay. So this is pretty straightforward, guys. Like this is very easy. I'll just do this really quickly. The pH of a solution is 5. What is the H plus? Is it acidic or basic? pH is equal to minus log base 10 H plus. Okay, I'll give you now a formula so that you can find the concentration without applying this. Instead of writing this, if they gave you the concentration of H plus to find pH, you do this. Let's say مثلا they gave you the concentration of is -4, you do minus log, you put it on your calculator. Okay, and you get 4. Okay, but let's say, like they said here, they gave you the pH, they want the concentration. Always know this. Concentration of H plus is equal to 10 to the power of minus pH. So in this case, it's going to be equal to 10 to the power of minus 5. Okay, in case they ask this. Let me continue because we're taking too long. Calculate H plus, classify. Okay, these are all easy. What's all? Okay, let's say you want to find the concentration of H minus. We know that what do? You just divide 10 to the power of minus 14. Listen, concentration of H plus times concentration of H minus is equal to 10 minus 14. So let's say you have H plus, you want to H minus, it's 10 to the power minus 14 divided by concentration H plus. Okay, and I don't even go through all this. I just do minus the powers, minus 14 minus the power of whatever. Like if it's as a power of 10, that's what I do. Anyway, I don't wanna yap too much. Characteristic properties of acids include this. Okay, acids react with metal. Okay, this is hold up. Okay. Is all of this required? Hold up. Yeah, okay, yeah, these are required. I'm gonna sum this up, the acids, and then you also have bases somewhere here. Was this a question? Yeah. Okay. Before I get to acids and bases, have all these notes here. Okay, bases is less, right? Yeah. So I'm gonna do first indicators before I do acids and bases. They're very, very easy. An indicator is a substance that changes color if it's placed in an acid or a base. So you need to memorize all of these. You need to know litmus turns red in the presence of acid and blue in the presence of a base. It's purple when it's neutral. Thymolphthalene is colorless, always colorless except for when it's with a base, it's blue. Methyl orange. So obviously its neutral will be orange. If it's acid, it's gonna be red. If it's a base, it's gonna be yellow. Okay. Phenolphthalein, again, is always colorless except for when it's pink. P for phenolphthalein, P for pink. Anything that has phthalene always is colorless for except when it's with a base. Okay. pH can be measured using a pH meter. When pH is measured, it should be reported using whole numbers. A universal indicator is a mixture of dyes. It's very useful. It gives a range of colors depending on a solution's relative acidity or basicity. This is the colors. Okay, you are required to memorize this. The way I memorized it is Roy G. Biv, the colors of the rainbow. Roy G. Biv. Okay, and green is the neutral position. So the acids are red, orange, yellow. The bases are blue, violet. Okay. طيب ماشي. We're done with the pH. Let's go now to acids and bases. Acids. أول شيء, you need to know the operational. You know, مانيش خلق أكتب. I think I'll just put a text box here. Okay. Operational definition of an acid. Okay. The first thing you need to know, conducts electricity when dissolved in water. Right? Okay. Second one, it releases H2 gas when reacting with a metal. We're going to do this in a sec. It turns litmus paper red. And 4, tastes sour. Operational definition. Then you have the conceptual definition of an acid. These are very important. Definition of an acid. You need to know that it gives H plus ions in water and increases the concentration, or no, thus increases the concentration of H plus. It is, in other words, a H plus donor. This must be memorized. Now we're gonna do the action of acids. Acids react with a few things. Acids react with three things. First, metals. How? Any acid plus a metal will get you a salt plus hydrogen gas. Okay? Always. This reaction will be discussed further in detail later. But for now, you need to know this. You need to know the metals. The metals that you use, actually, what they have to be? They can't be group 1, which are Lena Crypsis. Because for those of you who are asking, why can't it be group 1? Aren't they reactive? Yes, because they're too reactive. Right? Okay. It can't be copper or Ag because they're unreactive. They produce very little reaction. Okay, they're too weak. Okay, too weak. 3, it has to be moderate reactivity. Moderate reactivity, such as the group 2 metals or Mg, Zn, aluminium, or iron. These metals, yani. Okay, an example of it is مثلا magnesium, it's a metal, plus HCl to produce MgCl2. أكيد you have to balance it with 2 here, plus hydrogen gas, right? So this is just an example of what happens. 2, you need to know into what's important. Reacts acid plus metal to produce salt and hydrogen. These are very straightforward. 2, they react with bases. What do you mean? An acid plus a base again produces a salt plus water instead of hydrogen gas. Think of it like this: acid gives you H plus, base gives you OH. H plus OH gets you 2 hydrogen, 1 oxygen, which is just H2O, right? Okay. For example, by this is called a neutralization reaction. Okay. For example, HCl is an acid plus a base NaOH to produce NaCl plus H2O. You're going to need this later. If you're reacting two things and you want to know what's a precipitate, box up the middle. It's NaCl. Okay? Net iron is not important. Okay. And the third thing they react with are carbonates. And this was actually something we studied in chapter 2. Whenever you react an acid plus a carbonate, you get carbon dioxide, you get a salt plus carbon dioxide plus water. For example, HCl plus CaCO3 produces CaCl2 salt plus carbon dioxide gas plus H2O. Of course, you have to balance it. Okay? How did I get it CaCl? You box up the middle. Box up the middle. Okay? Now, we're done with acids. It's turn to go. It's the base turn now. Again, same thing. We had operational conceptual. Same thing. operational definition of a base. Okay, first thing, again, conducts electricity when dissolved in water. 2, it reacts with acids completely except for weak bases. Yeah, it turns litmus paper blue. 4, tastes bitter. 5, it's slippery. Okay, weak bases, by the way, like CaOH2. Okay, okay, this is the operation definition. Halla, what do we want? Conceptual definition of a base. Conceptual definition of a base. What is it? It dissolves to form OH minus ions, right? Base gets you OH minus. Okay, CO32 minus gets you OH minus carbon. Yeah, that's pretty much it. Let me just make sure. Ah, yeah. Also, it يعني okay. It reacts with the carbonate to form HCO3. Okay, this is you know what I mean. Eh, ما له طعمه. But okay. Uh, we now need to know the reaction of our bases. They react with. We have the two reactions. I'm not gonna write them. They're in the notes. They react with acids to produce salts, like we said here. Acid plus base. Where is it? Acid plus base neutralization reaction. Okay, base plus acid, same thing. Uh, these are just straightforward examples. And then also ammonium salts react with bases to produce ammonia plus salt plus water. Okay, let me see here. Yeah, so any ammonium salt plus a base gets you ammonia plus salt plus water. For example, here, NH4 ammonium nitrate plus KOH. This is the ammonium salt. Ammonium is NH4, huh? Okay, plus KOH with the base, potassium hydroxide. Any OH is usually a base. To produce NH3, like we said, ammonia gas. Ammonia is NH3. Ammonium is NH4. Plus the salt, KNO3. How do we know? U box up the middle, right? Plus H2O, which is a liquid. OH plus NH4 gets you, because listen, NH4 gets you NH3 plus OH. Okay, so OH, you get H2O. Anyway, هبل. Okay. After this, we're almost done the notes, guys. طولت عليكم, I know. Uh, but we have oxides, okay? I'm gonna sum it up for you very, very easily. Oxides. 4 categories. Here we're gonna put this. Oh no, I'll give some space here. Uh, here, here, and I'll give some. Oh no, I'll put it here. Okay. Oh, here. Let's go. The first one are neutral. The first ones are neutral, basic, acidic, or something new called amphoteric. Okay. Neutral oxides. Or let's start with the basic oxide. Basic oxides are the ones that are non-metals. Okay. Like Na2. Huh? Basic oxide, non-metallic. ox- Should be metallic, not non-metals, right? Metallic. Yeah. So why did I write non? My notes are wrong. Metals. They are metals. Like Na2O, CuO, CaO. And oxides, anything that just has O at the end. Okay? Type. Acidic oxides is basically metals. What are acidic? Non-metals. Like what? CO2, SO2, SO3, P4O10. Henny, it's these four, huh? And also SiO2. These are the most famous ones, the top three. Amphoteric is an acid plus a bit. Oh, tell me. Ah, this is what they react with. Oh, okay. I'm saying. It reacts with, okay. Hold up. Okay, yeah, never mind. I was saying something else. But this acid plus base, just keep it at the top now. We'll go back to it later. There are three amphoteric ones, which are ZnO, zinc oxide, PbO, and Al2O3. And then neutral ones, in some non-metals. What are they? H2O, CO, NO, N2O. Okay, memorize these, please. Okay, basic ones or acidic ones, they're pretty straightforward. But the neutral ones, amphoteric ones, you need to know them. Okay, طيب. We need to know uh, four things. Neutral ones don't react. Amphoteric ones react, but with acids and bases, right? طيب. So don't they react with acids and bases? These ones don't react. طيب, how about basic ones? Basic oxides. What do they react with? They obviously react with acids to produce, like earlier, what happens when you react a base with an acid? Salt plus water. Basic oxides also, they can react with water. You can dissolve it with water. If you dissolve a basic oxide in water, what do you get? You get a base hydroxide or metal hydroxide. I'll give you an example. مثلا a CaO here, dissolve it in water, H2O, you're gonna get Ca, sorry, Ca hydroxide OH2, because Ca2 plus crisscross it goes there. Okay. طيب, خلصنا basic oxides. هلا acidic oxides. أول شيء, like we said here, it can react with a base. Same thing to produce salt plus water. Acidic oxide plus base equals salt and water. Okay, we know this easy. Also, if you dissolve an acidic oxide in water, you get an acid, normal acid. Like, مثلا, acidic oxides, what are they? SO3, CO2, SO2, P4O10, SiO2. Any of them, you dissolve them in H2O, you're gonna get the acid. What is the acid? It's gonna be H2SO4 in this case. Okay? CO2 plus H2O, H2CO3. Okay. Yeah. So basically, what happens is just combine them if you're not sure what the numbers are. Also, like CO2 plus H2O. Like, see here, combine it. You're gonna get HC, three oxygens, O. Okay. I think that's it. Yes, that's it. We can now start solving the quiz. Okay. So metallic oxides are usually basic. They react with acid to give salt and water. For example, this and this. Non-metallic are usually acidic, and they react. Oh, why is it so small? They react with bases to give salt and water. Amphoteric oxides react with both acids and bases to produce salt and water. Examples include ZnO, PbO, and Al2O3. So the amphoteric ones react with both acid and base to produce the same salt-water reaction. Okay. Neutral oxides do not react. Okay, these examples. Let's do the quiz. Quiz should be now maybe 2 minutes. Really, I'm not even lying. Okay. Yalla. Which one shows that the underlying substance is not an acid? What does an acid release in water? It should release H plus. This one releases H plus, so it's an acid. This one, does it release H plus? No. This one releases H plus, so it's an acid. This one releases OH minus, so it's actually a base, right? Not an acid. Question 2. Okay, this is the Haber process quickly. What are the conditions for the best optimum conditions for Haber process? 280 and 450 degrees Celsius. So the catalyst in Haber is iron, and it increases the rate of the reaction, right? But it has no effect on the yield. Guys, this is old Haber process. And electrolyte. By the way, do we have Haber process? Chapter, all of chapter. An electrolyte is a substance that dissolves in water to give solution containing ions. I'm 100% sure they'll get this question. Maybe copy paste tomorrow. Okay. 4. Okay. At water at 25 degrees Celsius, what is the K water equal to? 10 to the power of negative 14, right? And at 25 degrees Celsius in pure water, the concentration of OH minus is equal to concentration of H plus, which they're both equal to 1 times 10 to the power of negative 7 molar, right? Okay. H2O to get H plus, plus OH minus, H2O, sorry. H2O when dissolved gets you H plus and OH minus. It's dissociated. Given that K water is equal to 1 times 10 to the power minus 14. When you increase the temperature of the system, it will absorb energy and the value of Kw will increase. Yeah, I guess just memorize this because it wasn't in any of the notes or any of the books. So if you increase temperature, it's going to absorb more energy, which causes Kw to increase because there's more energy. Okay? Common mistake is that students will say 10 to the power of negative 14 is bigger than 10 to the power of negative 13. I don't know what to tell you. A kid 10 to the power of negative 13 is bigger because its power is negative. Negative 13 is greater than negative 14. Okay, don't make this silly mistake. OH minus ions and H plus ions are present in all aqueous solutions, right? If something's aqueous, that means it dissolves to form ions. You're always going to have OH and H plus. Okay. Which ones are acids? Akid, is it the hydroxide? No. Is it never the hydroxide? Always HCl, HNO3, right? Guys, we should all know what acids are. What are the properties of acids? It turns blue litmus paper red. It releases hydrogen gas when zinc is added to the aqueous solution, right? It really, like, what is zinc? It's a metal, right? Metal. What happens when you add acid plus metal? You get salt plus hydrogen gas. Go back in the notes if you don't know. Remember, I wrote it here. Its aqueous solution, when you dissolve an acid, what happens? It conducts electricity. It has a sour taste, right? Like, these weren't in the notes. These were some stuff that are not in the notes that we'll get. Select the base here. Akid, we said the bases are the ones that are OH. Usually, all bases are OHs except ammonia, which is NH3. Okay. Either OHs or metallic oxides, like we did earlier. Remember, it can be metallic oxide. HNO3, HCl, we said they're acids. HCl, hydrochloric acid. HNO3, these are easy. Bases conduct electricity. It turns red paper blue, and it tastes bitter, right? Question 11. Element X is located on the left-hand side of the periodic table. The oxide of element X is metallic and what? Basic. If element X is on the left-hand side, what are located on the left? I know someone who got this wrong last week. I was very disappointed in them if they're watching this video. If it's on the left-hand side, it's a metal, right? Okay. So obviously it's gonna be a metallic oxide. What are the metallic oxides? They're basic. Non-metallic oxides in acidic, right? Question 12. Okay, this is past stuff. If the flame is yellow-orange, akid it's gonna be Na plus, yeah, sodium. If it's lilac-violet, it's gonna be K plus potassium. If it's gonna be crimson-red, it's Li plus. Question 13. Several different solutions, Okay. If you get reddish-brown precipitate fast, you know it's Fe3 plus. If you get a green precipitate that does not dissolve in excess base, it's Fe2 plus. Blue precipitate with sodium hydroxide that does not dissolve in excess sodium hydroxide. Anytime you see blue, we know it's copper. White precipitate with sodium hydroxide and no precipitate forms with ammonia. So, no reaction with ammonia. What is it? Calcium, right? Remember calzone? خلاص, I've written this table like 15 times on my channel. At this point, I'm not gonna write it anymore. White precipitate with ammonia does not redissolve in excess ammonia. Which one? Aluminium. Remember calzone. The one that reacts with ammonia but is insoluble in ammonia, that's aluminium. But the one that redissolves in excess ammonia is zinc. Green precipitate with sodium hydroxide, but this time it's soluble, it's chromium, right? Okay. What ions? We have the few ions that perform a white precipitate after you add K2SO4. To test for sulfate, you can either add Ca or Ba. Which ones form a white precipitate upon an addition of NaCl? White precipitate when you add Cl, what is it? AgCl, right? Remember, white precipitate, and if it was iodine, it's yellow. If it's Br, it's creamy. Remember these, the halides. Choose the ion that forms a creamy precipitate when you add KBr. So Br gets creamy. It's AgBr, right? So Ag is your answer. Question 15. Soluble in, okay. If it contains sodium, soluble. If it contains Ag with Cl, we know Cl is always soluble except with Ag and Pb, right? So wrong. It's not insoluble. It's no. BaSO4. SO4 is usually always soluble except with Ba and Pb, right? So it's insoluble. Kf. If it contains potassium, it's soluble. Na sodium. Potassium. Was potassium there? I think it was. I forgot. Wallah. Let me see. Somewhere here. Yeah, potassium was there. PbCl2, remember chlorine always soluble except with Pb and C and the Ag, so insoluble. BaNO3, if it contains nitrate, it's always soluble. 16. Okay. MgO, metallic oxide basic. Carbon dioxide, non-metallic oxide acidic. CuO, it's a metallic oxide basic. N2O, this is one of our neutral exceptions, right? Okay. CO, again, another one of our neutral exceptions. What were the neutral ones? Let's see. What were they? They were water, of course, H2O, CO, NO, and 2O. Okay. ZNO, it's one of our amphoteric exceptions, right? Zinc. SO2, non-metal, it's acidic. By the way, SO2 turns red litmus paper, turns blue litmus paper red because it's acidic. Al2O3, amphoteric. CaO, basic because it's a metal. Please memorize them, guys. I cannot tell you anything else. Here, they're all written here in front of you. Okay. Calculate the concentration of hydrogen ions in a 0.6 molar of KOH. Okay. They want you to find H plus. Guys, it's so easy. So easy. Okay. KOH. Always, when you get any question like this, you write the dissociation. You get K plus and OH minus. Okay, what's the concentration of OH minus? We don't care about the other one. We only care about H and OH. What concentration of OH minus? It's the same as the KOH, which is 0.060. So 0.060. Are they asking about H plus or OH? Asking about H plus. How do we find that? We always divide 10 to the power of negative 14 by the concentration of OH, right? So 0.06. And you're going to get, like, let's put this on a calculator. 0.06. 1.7 times 10 to the minus 13. Okay. Student wants to find concentration of hydrogen H plus and OH in H2A. It's a strong acid. It forms a complete dissociation, right? Okay. How do you calculate it? Already, again, same type of question. You write the dissociation, H2A. Dissociates to form A plus 2H, right? Usually it's just A and H. Okay, let's say I wrote H, yeah? The dissociation has to be balanced. Is it here? It's 2, here it's 1, so I have to multiply by 2. Okay, how much is the concentration here? 0.4. And I don't care about the A or whatever, any other element. All I care about is the H plus and OH minus. What's my OH and what's my H plus? Its coefficient is 2, so I multiply the 2 by 0.4, so my concentration is 0.8, right? طب ماشي, 0.8. This is the concentration of H plus. You go, you put 0.8, they want 3 SF, so 0.800 m. OH, how do you find it? You always divide 10 minus 14 divided by what you have. Let's see here. (1.25 times 10 minus 14). A student is asked to find the pH of a solution. In this experiment, he prepares an aqueous solution of hydrochloric acid by dissolving 0.08 moles of the acid in 250 ml. La 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 la. أول شيء they said calculate the concentration of H plus. How do you find the calculation of H plus? Same thing we've been doing. Anytime you want a question like this, you have to dissociate it. Hydrochloric acid. Anybody who doesn't know what hydrochloric acid is in grade 11, guys, this is haram عليك والله. HCl. Dissociates to get H plus, Cl minus, right? Okay, we need the concentration of H plus. So it's the same coefficient, so you just take the concentration of HCl. Do I have it given? If you put 0.08, I don't know what to tell you, صراحة. This is moles. We want M, the concentration. We have the moles, we have the volume. Can we find concentration? Of course we can. 0.08 over 0.25. Why, Walid, is it 0.25? Because it has to be in liter, dm cube. So to convert, you have to divide by 1000, right? So 0.08 divided by 0.25, let's see. Uh, 0.32, right? So the concentration of H plus, how much? 0.32 m, right? So you put 0.320 because 3SF. Deduce the pH. How do you find pH? pH is equal to minus log base 10, the concentration of H plus. So what do? You put minus log base 10 of 0.32. Let me show you how you do it. You take here. Every calculator should have this log square. Log base 10. Base is the number that goes down. So enter you want minus, right? Remember, put minus. Minus log base 10, 0.32. So the pH is to 3 decimal places 0.495. Okay, very important. If you get a negative answer for your pH, you did something wrong. Always the answer should be positive, okay? A strong electrolyte is the one that dissolves and exclusively gives ions. Exclusively يعني fully gives ions, okay? Strong. أكيد, not weak. Okay, weak dissolves only to a limited extent. Very easy. Our last question for today. Oh, okay. Okay, the contact process, very easy. Very easy. After reacting molten sulfur with air, so they reacted S plus oxygen in the air, they got SO2, right? Very straightforward. And they mixed the SO2 with more air to make a product A, right? Product A is then dissolved in concentration of sulfuric acid to form product B, and the final step product B is dissolved in water to use the final product sulfuric acid H2SO4. We don't care. Yap. Okay, here. They want what's product A. If you are reacting SO2 plus O2 in the contact process, what do you get? SO3. Okay, this should actually be double arrowed, but anyway. What are the conditions of pressure and temperature? It should be 280 m and temperature 450 degrees Celsius, right? Okay. In kilopascal, how much is it? Always from ATM to kPa, you multiply by 100. But from ATM to PA, you multiply by 10 to the power of 5. Anyway, so 2 times 100, 200 kPa, because they asked it in kilopascal in the exam. What catalyst is used in the contact process? Vanadium 5 oxide. Thank you so much for watching. يعطيكم العافية.